Good morning, everybody. So, during the previous lectures, if I take it, the first lecture we focused on fundamentally what is an open channel flow, then what are the types of channels, then what are the types of flow. That was our first lecture discussion. The second lecture we discussed on the velocity distribution, and after the velocity distribution, what are the geometrical properties which are very important while solving any problems related to open channel flow, mainly focused on the wetted area, wetted perimeter, hydraulic radius, top width, and finally hydraulic depth. These are the five. And this we have done for rectangular channel, trapezoidal channel, circular channel. So now you may get a doubt how we are going to use them. So the continuation part of it is the next one is what are the equations for uniform flow for discharge calculations. While calculation of the discharge, first we calculate the velocity, and velocity multiplied by the area of flow section will give you the discharge. So what is the channel discharge? If you want to determine, then what are the equations you are going to use? What's the basis for those equations? How you are going to do it? That we will take up. Once we do it, then the next question we will ask is for rectangular channel of given dimensions, how you calculate the velocity, how you calculate the discharge. Similarly, for trapezoidal channel, same question. Similarly, for circular channel section, same question. So if that we do it, that's the real, we are able to really understand the open channel flow. First type of calculations. So let me straight away take into the uniform flow formulae that I will take into. So I'm here with sharing the, so in this lecture, we focus on uniform flow. When flow takes place in an open channel, when flow takes place in an open channel, what will happen is two types of forces develop. Number one is force causing the flow, causing the flow. Second one is the force resisting the flow. The force causing the flow is basically the slope is mainly responsible. The slope of the channel is the main component. Then again, what is that force if you want to calculate? It is nothing but the weight component of water in the direction of flow. And this is how it has come. This has come because of this. Otherwise, without this, this won't be there. So this is mainly responsible for the flow. So the force causing the flow is this. This is the force causing flow. Right? Next. What is the second? Which one force is resistance actually? The resistance force, resistance number two is mainly the channel bed and sides. This is, they offer resistance to flow. This resistance is the shear resistance. And for uniform flow, the force causing the flow should be equal to the force resisting flow. Then naturally the flow will be uniform. This is what we want to tell it. So what is the force causing the flow? The weight component of flow in the direction of flow. Whereas what is the force resisting flow? The frictional resistance. This is nothing but the frictional resistance, or that is also called as shear resistance, whatever you call it as, the frictional resistance. Both, if they are equal, then when these two forces are equal, the flow becomes uniform flow. There are different, basically, scientists who have done actually different experiments based on extensive experimental investigations. Experimental investigations. Many uniform flow equations are developed. What are this uniform flow thing is? Number one is Chezy's equation. This is number one. Number two is Manning's equation. This is number two. Number three is again from Chezy's only, he has taken it, Basin's equation. And again, one more also from Chezy's only. This is Putter's equation. So these are all the things. Out of this, the first two are very popular and widely used. Right? But Basin also, because he is basically, to, if I remember correct, then he is a French scientist actually. The Chezy is a French scientist. Mannings is Irish actually, to my knowledge. Then again, Basin is again French actually. Cutter is basically an European. These are like, so first Cherry's equation was the first, then Manning's equation. These two are very popular. What is Cherry's equation? Cherry has given an equation for velocity as V is equal to C root or S. V is the mean velocity. R is equal to hydraulic radius, which is equal to A by P. S is equal to the slope of the channel. So this is the thing. And C is equal to Chezy's coefficient. This, as this equation is a non-dimensional equation, Naturally, the C value depends on the system of units which you are using. So, if generally you go in SI units, it will be around 40, 50, 60, 100, 80 in that order actually. If you use SI system and if you change the system, the C values again vary. So, this is the first thing. Then I will go into the second one, Manning's equation. So the Manning's equation is equal to V is equal to 1 by N R to the power of 2 by 3 S to the power of half, where again V is equal to mean velocity, R is equal to hydraulic radius, which is equal to A by P, S is equal to channel slope. These are the three. And N is equal to N is equal to what is N actually? It is Manning's coefficient. These are all the things first. So if that is the case, then and on what factors this Manning's, and because this is Manning has further explained what are the factors that govern this, mainly the surface runoff, surface roughness of the channel, because if it is red then channel, what is the surface runoff? Irregularities of the channel bed, irregularities of channel bed, then obstructions to flow. These are all some of the factors. So just idea is to have an idea what are the factors on which this depends upon. Then probably sometimes it depends on size and shape of channel. Size and shape of channel also it depends upon. Then it depends upon basically the depth of flow and discharge. So on these are all factors, etc. There are some more factors, but just I outline some of the things. So this is second thing. The third one is the Basin's formula. Basin's formula is again only Chezy's formula, but only thing is he has defined what is C. Basin has defined the equation for C, that is C equation he has developed. So for as far as the Basin's formula is concerned, C is equal to 87 by 1 plus m by root r. In this, m is equal to Basin's coefficient and r is equal to a by p. Right? This. So the generally what Basin has done is he has given the m values. These m values are for different bed materials. He has specified for different bed materials. He has given different values because ultimately the frictional resistance only, that is one of the important factor. So this m value varies between 0.11 to 3.17. This is how the m varies. And what is that actually? For if you take it from this m 0.11, I can take it very smooth boundary. You can take it, and basically 3.17 is rough boundary, rough basically. Based on this, he defined these values. So once he defined these values, it became very easy to get C. And once C is obtained, again use the Chezy's equation. That is it. Like that, Kutter also has given one more equation. Fourth one, Kutter, you can just, if you possible, remember it, or otherwise, for don't worry much. Only I'm giving you a just one more equation, a Kutter's equation. Again, he also used V is equal to C root RS, but he has given an equation for C which is a little bit difficult. 23 plus 1 by n plus 0.00155 by S. This is all numerator divided by 1 plus 23. Same, all this you can write plus 0.00155 by S into n by root r. So in this, S is channel bed slope, you know it, which r is equal to a by p, you know it, which is the only thing is the n is Kutter's n. So Kutter tried to give the n values in this equation. So these are the four equations which are useful for determining the velocity, and then thereby discharge is equal to velocity into area. So kindly remember that using any of these equations, we can find out the discharge in open channels. So number one is Chezy's equation, V is equal to C root RS. Then Manning's equation, V is equal to 1 by n r to the power of 2 by 3 s to the power of half. Then Basing's equation, use Chezy's equation, C is equal to basically 87 divided by 1 plus m by root r. Last Kutter's equation, again Chezy's equation, C root RS, C is equal to 23 plus 1 by n plus 0.00155 divided by S. All that numerator divided by the denominator is 1 plus bracket open 23 plus 0.00155 by S into n by root R. So this is what the thing. Then next, last, before closing this topic, what is the relation between Chezy's C and Manning's N? What is the relation between the two? So if I write V is equal to C root RS1, V is equal to 1 by N R to the power of 2 by 3 S to the power of half. If I equate these two, then what I will get? C into R to the power of half S to the power of half is equal to 1 by N R to the power of 2 by 3 S to the power of. So S to the power of half will get cancelled. If s to the power of half, this if cancel. So therefore, what will happen? C is equal to, if I take it, 1 by n into r to the power of 1 by 6, if this it goes. So this is the relationship between this. And what are the general Manning's n values? The Manning's n values, general values I am talking about. The Manning's n, actually, if you take a very smooth cement cement paved channel, aligned channel, if I take it, it may vary 0.010 to 0.014. Then if you take an earthen channel, for example, earthen channels offer more resistance. So it may be 0.020 to 0.030. And if I take gravel instead of that, the channel material is that, then it will be 0.022 to 0.035. Then if I take earthen completely earthen channel, but some of the channels earthen channel with vegetation, so inside also all vegetations, if vegetation you find it out, then it may vary 0.05 to 0.040. This is how it varies. So the only idea, zero point zero 0.01 very smooth, 0.025 to 0.040, what you call it as channel with complete vegetation. So now just I will show you one thinking, one the idea of how to do it also. So already I mentioned about the Chezy's equation. Now our job in the next unit is how to do some problems, especially using this Chezy's equation and Manning's equation, especially for discharge determination and velocity determination. That we will take it, so that with that we accustom to how to calculate wetted area, how to calculate wetted perimeter, how to calculate basically what you call it as the hydraulic mean depth, how to calculate the top width, how to calculate the hydraulic depth. So these are all the things that which we do. We do one rectangular problem, one trapezoidal problem, and one circular problem, so that we understand how to do it. Once I complete that, you are reasonably good in understanding the uniform flow and solving the problems. Okay. Thank you so much.
Like, share, and subscribe. Hit the bell icon for more updates.